I agree. It's National Fatten You Up Week, I guess. Candy Day yesterday, and there's 2 donut days in the year. There's 2 National Donut Days. One on June 1st and one today. Again, I found all this out an hour ago when I put in Happy Donut Day in there. Yeah. Okay. Alright. So, just a reminder that this week, Friday, you're going to have a formative, and then next week, Friday, you're going to have a test. Okay? We did tweak the schedule just a little bit. Tomorrow we were supposed to do a station rotation review type thing, but we're going to push that back to the actual review next week, Wednesday. That will be then your review. And we're going to throw the kitchen sink at you tomorrow again. But this time we actually know what we're talking about because now we've talked all about it. Okay? All right? So, today you are on that worksheet that we have, that I gave you. You probably want to just wait until we let you know what we're doing on it before you start on it. Okay? I love the enthusiasm, but we're going to tweak things up a little bit just on that sheet too. Okay? So, before we start, let's talk about A, B, C, and D. What does A control? Amplitude. So that's the... So, it kind of stretches it out vertically. Okay? All right? What else does A control? What do you mean if it's positive or negative?
Flips it.
It flips it. So if A is negative, it flips one or both of them? Both. It flips both sine and cosine. Okay? So if A is negative, it flips the graph over. Okay? So it controls the height, or the vertical stretch, and the flippedness. B. What does B control? The period. What's the period? No. What's the period?
The accordion.
The accordion. So it's the horizontal distance. Okay. So B controls your horizontal distance. C. What's the only thing that C controls? Where you start. Okay. So B only controls where you start. Okay. D. What's the only thing that D controls? Your middle value, your vertical start, if you will, the vertical middle. Okay? Now, there's a crazy combination of the rest of them. Okay? A and D control your high and your low and your range. Okay? C plus B is your end value. Okay? So there's some combinations within all of those. Okay? Today, what's going to happen is we are going to go in reverse. Instead of us asking you to produce the first lap wave, we're going to give you the function and ask you to produce the equation. Okay? So there's a lot of things that happen in that equation. Okay? That equation is, or your function is locked in between an upper bound and a lower bound. Okay? So it's locked in between a high value and a low value. And it will stay inside that band all the way forever and ever and ever in both directions. Okay? Well, halfway between those is the middle, which is your D value. Okay? Then you are also able to find the amplitude, which is your A value. it's going to start somewhere. It's going to end somewhere. Again, that depends on what kind of a function you're making. If you're making a sine function, you need to find that middle point because sine starts in the middle and goes to the, I don't want to say the next middle, but it's the next middle. Okay? It goes 2 middles afterwards. Okay? If it's a cosine, you need to find that high and then go to the next high. Okay? So that gives you your period. And that's equal to 2 pi over b. So you can find b then from that. And then this start value down here is your C. So that's where we find our A's or B's or C's and our D's. Okay? Let's do this. So on this first one, I want us to find, you want to find a sine or a cosine curve first? Sine, okay. So on this one, we're going to find a sine curve. Then on the next one, you'll find a cosine curve. Okay. So based off of it, what is our high value? What do you got? -4. What is our low value? -14. So if my high is at -4 and my low is at -14, where is my middle? -9? And that is my D value then, yes? Okay. We wanted to find a sine function, so we need to start at the middle, right? Sine goes middle up or down? Middle up, okay? So we want to find a middle that's going up. This here is a middle going down. So I don't want that one. Whoops, tap the brakes. I don't want to recognize. That's a middle going down, so I don't want that one. So I'm going to start here at my middle going up. So here would be the function that I am trying to find right there. Okay? If that is the case, what is my starting value? -1. So that's going to be my C value. If I start at the middle and I end back at the middle, what is my period? Not 11. Count again. 12? Okay. Because I started here at -1. I ended here at 11. So that gives me a distance there, a period there of 12. So then I can figure out the period is equal to 2 pi over b. So in this case, 12 is going to equal 2 pi over b. So b is going to equal 2 pi over 12, or b is going to equal pi over 6. Our distance from here to here, or from here to here, is how much? What's that distance? 5? So that is my, those are bad. I don't know why those all of a sudden decided to get all funky. So that is my A value. So now I can write my sine function. So f of x is going to equal 5 sine of pi over 6 times the quantity x minus negative 1, so I'm going to put plus 1, then minus 9. Is that the only sine function that we could have come up with? No? Come up with another one. Another sine function for this curve. All we would need to change would be that number. And as long as that number is 12 away, because 12 is my period, that would work. Okay? For one tweak. So right there, there's 5 functions that all fit that graph. Okay? Or we could change to a negative A value. If I change to a negative A value, now instead of plus 1, now I would be starting at x equals 5. And then again, change the color on these. So then this could be negative 17, negative 29, positive 7, positive 19. Okay? As long as they're off by 12. Okay? Likewise, we could have gone with a negative B value because it's a sine. And then we would have also been in this, on this side. If we went negative A and negative B, then we would be on the left side here. Okay? Handle that? What I would like you to do now is, for the second one, I would like you to come up with a cosine curve for me. I've got a high value at 7, a low value at -3, which puts my middle at 2, which makes my amplitude here to be 5. We wanted a cosine curve, so I'm going to start at -2. So that is going to be my C value. My period is going to go from -2 to +6. So that gives me a period of 8. So that gives me a period of pi/4. A, B, C, D is my middle. D is my middle. So therefore my cosine curve would be 5 cosine of pi/4 times the quantity x plus 2, then plus 2 again. Yes? Period being 8, that means then that these could all be differing by 8. So we could go plus 10, plus 18, minus 6, minus 14 would be the 5 around it. Or we're down to minus 2. And then plus 2. If we went with a negative A value, these again would all be off by 8 there. Questions, comments, concerns, clarifications? Good? Flippity floppity? Let's talk extreme tides. So this is up in Alaska. Notice where the water level is right now. Okay? And as the tide comes in, that water gets higher and higher and higher. And then as the tide goes out, it would get lower and lower and lower again. This is a time lapse of a dock up in Alaska. I was once at a fish boil at a dock similar to this in Alaska, and the people that we were at, there was like a little island over here and a little channel, and it was dry, and they're like, if you're going to go over there, you got to be back in an hour, because anything after an hour, it would have been underwater because the tide was coming in. And then the tide will go back out.
Is a diesel motorhome on your bucket list? Stop dreaming. Great American RV has over 70 diesel coaches.
So that doesn't keep playing. Okay. So, throughout the day, the depth of the water at the end of a dock varies with the tides. The table below shows the depths in meters at various times during the morning. We know that the high tide is at 4 a.m. So this is high tide. We know that the low tide is at 10 a.m. So low tide is there. Important? Why are those important to us? That we know when high tide and low tide is. That's our high and our low of our function, then, right? Okay, so that sets everything. The depth of this water is never going to be more than 4.40 meters, and it's never going to be less than 1.8 meters. Okay? So then it says, graph the data points. Okay? All right, well, let's graph our data points here now. So we can make just a regular old graph. We would have depth here. And we would have time here in hours. I'm going to also make the executive decision to switch to military time, and so that this would be 0 a.m. instead of 12 a.m. Okay? Which would make midnight then be 24. Okay? Because it would be the 24th hour. Okay? Okay? So 0 to 24. Okay? So our depth then would be 1 meter, 2 meters, 3 meters, 4 meters, 5 meters. 2 a.m., 4 a.m., 6 a.m., 8 a.m., 10 a.m., noon, 2 p.m., 4 p.m. Huh? .55 here at hour 0. Hour 2, 3.8. Hour 4, 4.4. Bless you. Hour 6, back to 3.8. Hour 8, 2.55. Hour 10, 1.80. Noon, 2.27. Agree with me on that graph so far. Given this set of data, which is going to be easier to find, a sine or a cosine curve? What do you think? What are you thinking? Sine? Sticking with it? I don't know. You haven't given me any justification why.
Because it's already like this.
Okay, because it looks like a sine curve? Okay, right? What do we need for a sine curve? We need the middle, right? Okay? And we need to know exactly where the middle is, right? Okay, well, let's figure this stuff out. So my high is 4.4, yes? My low is 1.8. So where would my middle then be? At what? 3.1. Do I have a 3.1 data set in my data? No. So does it make sense to do a sine? Nope, it doesn't. Okay. All right. What do I need for cosine then? Where does cosine start? At high. Do I have the high value? Yes. Or cosine could start at the low value, right? Do I have the low value? Yeah. So it makes sense for us to make a cosine curve out of this one. Okay? Okay? So anytime that we have a set of data, it makes more sense to do cosine because then you know your high, you know your low. Those could be your two starting points. Okay? All right? So I've got my middle. That is my D value. I've got my amplitude. What is my amplitude? What do you got? 1.3. That is my A value. Where would it start? If we're doing a cosine, where would it start? At 4. Okay. What would the period then be if it starts at 4? The period. You tell me. You gave me two numbers. Let's use some logic here. I know. Making you think. What do you got? 12? Why 12? From on a cosine curve from the high to the low is half of the period, right? Okay? So from 4 to 10 is half of the period. So that 6 hours is half the period. So the whole period then would be 12 hours. Okay? All right? So from here to here is half the period. So then the whole period would be 12. Which makes my B value then be what? What's my B value if my period is 12? Pi over 6? So if it's 12 equals 2 pi over b, then we can switch the 12 and the b, so it's pi over 6. Middle amp, so then my start would also be my C value. So my equation would be depth over time would be 1.30 cosine of pi over 6 times x minus 4 plus 3.10. Would you agree with that? Yes? Okay. All right. Part C says now we need to find the depth at 9 a.m. So what am I going to do to find the depth at 9 a.m.? Plug in 9 for x. Oops, sorry, I should have put t there. My fault. So it was a function of t. Let's go with t because it's time. But we can call it still x. Yep, so plug in for x or for t. Okay, so I'm going to plug in t equals 9 into my calculator. Now, here's the kicker. Because we are using 2 pi over b to find our b value, your calculator needs to be in radians. So if you're using your own calculator, you need to be in radians. If you're using our calculators, you need to make sure that you've got RAD up there in the corner. So you can just type it in, 1.3 cosine of pi over 6 times the quantity, 9 minus 4, close and close, plus 3.10. So your depth then should be 1.974 meters. Which makes sense because 9 a.m. is right there and 1.974 is in between 2.55 and 1.80. Okay? For 3 p.m., what are we going to put in our function? 15. T here is now 15 because 3 p.m. would be right here, which would be 15 on our scale. Now, the nice thing about the calculators, come on, there we go. Nice thing about the calculators is you can go up and you can highlight it and hit enter, and it pulls it right back down. And then you just change the 9 to a 15. And you get 4.226 meters. Good? Okay. Now, it says a boat needs at least 3 meters of water to motor to the dock, or motor at the dock. We need to find during what times in the afternoon is it safe for that boat to motor in and out of the dock. Well, what we're going to have to do is we're going to have to graph this function. Okay? So now we're going to go back in and we're going to make ourselves a graph. So I'm going to hit Control Dock, gets me a new page, and on that new page I'm going to add a graph. Again, making sure that I'm in radians. Now I'm going to type in my function, 1.3 cosine of pi over 6 times the quantity. Instead of t now I'm going to use x because I'm in a function of x minus 4, close, close, plus 3.1. When I hit enter, I get that. I'm only going out to 10, so I should probably adjust my window because I need to go out to at least 24 because now I got 24 hours in a day. Okay? It said that we needed to motor in at 3 meters, so I'm going to hit tab, and then I'm going to put in a 3 meter line. So that is my 3 meter line. It said in our problem we want to be in the afternoon. So what time does the afternoon start? 12, so 12 p.m. it starts, and afternoon ends sometime before midnight, right? Okay, so I'm looking here specifically at before 12. Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I would be looking at these two right in here. So I'm going to analyze my graph for an intersection. I get, there's my first one. There's my second one. Okay. Now I want to be able to draw on it, so I'm switching over to here because there's the same thing. Okay. So what time frame is this right here? What time during the day is that? What? Almost 1. Could we be a little bit more specific? I would call it 12:51 p.m. How did I get 12:51 p.m.? 0.853 times 60. Okay, 0.853 times 60 is 51.18. We'll call it 51. Okay? What time of the day is this one? What time of the day would 19.147 be? 7:09? You think so? Agree with 7:09? I thought it was 7:08.
8.82.
8.82? Okay. I would probably go with 7:08 then. If it were my boat.
0.82.
Right. But you know what I mean? If it's my boat,
Yes.
you know what I mean? I would just drop it. I wouldn't round it. I would just drop it.
Yeah, I guess. It's going down.
Because it's going down? Yep. But that's just me.
I wouldn't know. I don't have a boat.
I know. Neither do I. But I would probably want to protect it if I had it. Questions on this one? So you should be able to now be through number 14 in your homework packet. Okay? That homework packet will be due next week, Friday.